Case study: AI-driven vulnerability management, transforming cybersecurity practices in financial institutions. The WannaCry ransomware attack of 2017 was a stark reminder of the critical importance of vulnerability management in cybersecurity. Ahmed, the chief information security officer of a mid-sized financial institution, vividly remembers the frenzy that ensued as news of the attack spread. The organization, like many others, relied heavily on Microsoft Windows operating systems, making it a potential target for the ransomware, exploiting a specific vulnerability known as Eternal Blue. The institution's cybersecurity team, led by Ahmed, had been traditionally using manual code reviews and penetration testing to identify vulnerabilities. They were effective, but often time-consuming and resource-intensive processes. Recognizing the need for a more efficient approach, Ahmed had recently advocated for integrating AI technologies into their vulnerability management framework. However, the implementation was still in its nascent stages. When the WannaCry attack hit, Ahmed's organization was among the fortunate ones. They had recently deployed an AI-driven vulnerability scanner that had flagged the Eternal Blue vulnerability. This early identification was crucial. The system was able to analyze large volumes of data rapidly, identifying patterns and potential security flaws that might have gone unnoticed in manual reviews. It prompted Ahmed to wonder, how can AI-driven technologies consistently outperform traditional methods in identifying vulnerabilities? The key was automation and the ability to process vast amounts of data to uncover patterns that indicate security threats. Upon identifying the vulnerability, the next step for Ahmed's team was classification. Given the high risk associated with Eternal Blue, it was essential to prioritize remediation efforts. The common vulnerability scoring system was employed to rate the severity. However, Ahmed noticed that the AI system provided real-time analysis of threat intelligence feeds and historical attack data, predicting the potential impact and likelihood of exploitation. This led him to question, can AI-assisted classification provide more accurate risk assessments compared to traditional CVSS methods? The AI's ability to continuously analyze and learn from new data proved invaluable in prioritizing threats effectively. The urgency to remediate the vulnerability was palpable. Ahmed's team sprang into action, applying patches and updating systems. This phase typically required a comprehensive understanding of the IT environment and the interdependencies between different systems, which was often a daunting task. However, the AI-driven tools recommended the most effective remediation strategies based on past incident data and the current threat landscape. Ahmed pondered, what are the potential pitfalls of relying on AI for remediation strategies? While the AI provided efficiency, it was crucial to ensure the data quality and completeness to avoid false positives or negatives. Despite their efforts, some vulnerabilities could not be fully remediated, necessitating mitigation strategies. The AI systems continuously monitored network traffic and user behavior, detecting anomalies that might indicate suspicious activities. Machine learning models trained on normal user behavior patterns flagged potential threats in real time. Ahmed realized the importance of early warnings in minimizing damage and questioned, how effective are AI systems in detecting and responding to real-time threats compared to traditional methods? The AI's capability to provide early warnings and automate response actions significantly reduced the potential damage from unremediated vulnerabilities. The integration of AI into the institution's vulnerability management processes yielded significant benefits. Ahmed noted that the average time to identify and contain vulnerabilities had reduced by nearly 27%, a figure supported by studies indicating similar results in organizations using AI and automation in cybersecurity operations. This raised another question. What are the long-term benefits of AI integration in vulnerability management beyond immediate efficiency gains? The continuous learning and adaptation capabilities of AI technologies ensured that the institution stayed ahead of evolving cyber threats. Despite the successful mitigation of the WannaCry attack, Ahmed was keenly aware of the challenges that lay ahead. One of the primary concerns was the quality and completeness of data used to train AI models. Any inaccuracies could undermine the effectiveness of AI-driven tools. Ensuring transparency and explainability in AI models was also crucial for building trust among cybersecurity professionals. Ahmed reflected, how can organizations ensure transparency and accuracy in AI models for sustained effectiveness? Continuous collaboration between AI experts and cybersecurity practitioners was essential to address these challenges and optimize the use of AI tools. The rapid evolution of AI technologies necessitated ongoing learning and adaptation. Ahmed emphasized the need for his team to stay abreast of the latest advancements in AI and integrate these technologies effectively into their existing frameworks. This required regular training and a proactive approach to understanding emerging risks. Ahmed's final reflection was, how can cybersecurity professionals balance the integration of AI technologies with the need for continuous learning and risk management? The key lay in fostering a culture of continuous improvement and collaboration within the organization. In conclusion, vulnerability management within Ahmed's organization showcased the transformative potential of AI technologies in enhancing cybersecurity practices. The early identification, accurate classification, efficient remediation, and proactive mitigation of vulnerabilities underscored the benefits of integrating AI into vulnerability management processes. However, the journey also highlighted the importance of data quality, model transparency, and continuous learning. These elements were essential in ensuring the sustained effectiveness and trustworthiness of AI-driven tools in safeguarding the organization against evolving cyber threats.